Okay, finally we can get into what is probability. So let's start talking about probability. First of all, probability starts with some sort of experiment. And experiments are basically those experiments that do not yield the same results each time they're performed. In other words, regardless of how carefully they're repeated, you cannot guarantee the outcome with 100% certainty. You can go ahead and read this, so I don't have to read it to you, but basically it just shows you some different areas where probabilities could be used and some random experiments that we might want to calculate probabilities from. But there's, thousands and thousands of different experiments that use probability. So those are just a few examples. Now, before we get into this, we need to talk about what is a sample space. A sample space is the set where you formulate the set of all outcomes in an experiment in such a way that in each trial of the experiment, one and only one event or outcome in the set can occur. We call this set the sample space, and we can use the letter S for the set. And each element in the sample space is actually called a simple event or a simple outcome. So look at example 1. Suppose a single die is tossed. We could let the sample space simply be all the possible outcomes of the die. So whatever we roll, it will match one and only one of those outcomes, 1, 2, 3, 4, 5, or 6. Now we could say the sample space was going to be even or odd. But so if we roll a 2, we know it's going to be even. We roll a 4, it's going to be even. Roll a 5, it's going to be odd. Now that satisfies the definition, but generally the sample space we use is going to be one that will give us the most information about the outcomes. And likewise, you could actually do something like let S be a number less than 3 or greater than or equal to 3. So you could have two possible outcomes like that, but if you did that, then again, it wouldn't give you as much information, because if you know a number is less than 3, then you don't know as much about the number as if you do if you know the number rolled is 2. So generally, we'll use the sample space that gives us more information about the elements than one that gives us less. Now, simple events. What are simple events? If the sample space was 1, 2, 3, 4, 5, 6 from above, then each element is actually called a simple event. The 1 is a simple event, the 2 is a simple event, and so on. If we toss 2 coins and observe their outcome, we could let the sample space be both coins are heads, the first coin head, second coin tail, the first coin's tail, second coin's head, or both coins are tails. Well, in that case, head-head would be a simple event, head-tail would be a simple event, tail-head would be a simple event, tail-tail would be a simple event, and so forth. Now, simple events can be denoted by lowercase letters. So, for instance, here we might say E1 would be the simple event head-head, E2 the simple event head-tail, E3 the simple event tail-head, E4 the simple event tail-tail. The ordering really is not that important, what order you put them in. Now, let's say if we selected 5 cards from a standard deck, a simple event could be just pick any random 5-card hand, and this would be one of the 2.5 million simple events that are possible. Because remember, if you do 52 choose 5, you can actually find out how many simple events are possible for that experiment. Now let's talk about event spaces. An event space is defined to be any subset of S. So an event space can be the entire set S, or it can be the empty set. If our event E contains only one event from the sample space, then we call E a simple event. If it contains more than one event, then E is a compound event. So let's go back to this example. Let's suppose a single die is tossed. So I'm going to use the sample space I gave you earlier, 1 through 6, and let's look at some different events. So let's say E is the event that I get all even number rolls. Well, then that would be 2, 4, or 6. So E would be a compound event. So let E be the event of rolls greater than 5. Well, there's only one event that gives me a roll greater than 5. So that's actually a simple event since it's only one element from the sample space. How about rows divisible by 3? Well, the only numbers divisible by 3 are 3 and 6. But that would still be a compound event because it contains more than one simple event. How about rows divisible by 5? Well, that would be a simple event because only one element is in there, 5. How about rows less than 0? Well, that would be the empty space because you're not going to roll a die and get a value less than 0. What about rows less than 10? Well, everything from the sample space would be in that because all of the rows are actually all of these rows. So the event space would be 1 through 6, which is also the same as the sample space. All of these rows are less than 10. Okay, another example would be, suppose we select a card from a standard 52 card deck. So let the sample space consist of the set of all 52 cards. Now I can't list them all, there's just too many to list. So let's let E be the event of selecting the king of clubs. Okay, now this would be a simple event because only one element would give it to you, and that would be the king of clubs. Now let's say E is the event of selecting a king. Well, now this would be a compound event because there's 4 ways to get a king: clubs, diamonds, hearts, or spades. Let E be the event of selecting a green card. Well, that is not possible because in a standard deck the cards are either red or black. And then if you said let E be the event of selecting a card that's red or black, well, that's everything because it's, like I just said, all the cards are red or black. Now there's 2 types of probability that we're going to talk about. Theoretical probability uses basic assumptions and reasoning to determine probabilities, whereas empirical probability is determined through experimentation or collecting data. And so let's look at some examples. Theoretical. A coin is tossed. We say the probability of heads is 1/2. Okay, well, did we do any experiments to come up with that? No, we just used basic assumption. A pair of dice are tossed, and the probability of rolling a sum of 7 is 1/6. Well, it's not like we're going to roll a pair of dice 1,000,000 times and figure out what percent it's going to come up with a sum of 7. No, there are 6 ways out of 36 to get a sum of 7, so we say 6 out of 36 is 1/6. A 5-card hand is selected from a deck of cards. The probability of receiving a royal flush, well, a royal flush, there's 4 ways to get a royal flush out of, remember, the over 2.5 million possible 5-card hands. So again, all of these here are theoretical, but over here we gather the probabilities based on empirical data. So a thumbtack is tossed. The probability of it landing point down is 0.77. So maybe we tossed it 100 times and found that it landed down 77% of the time. A domino is tossed. It can land on a flat side, edge side, or inside. And we determine the probability of landing on its inside is 0.05 because we tossed it 1,000 times and it landed on an end only 50 of those 1,000 times. Or a client bought auto insurance for his car. The probability that he files a claim during the first year is 0.00125 because only 0.125% of people in his category file claims. Or the probability that it will rain today is 80% because of the past days similar to today, it rained on 80% of those days. So all of these under the empirical column are based on, what did I say? Experimentation or data. And those on the far left column are based on reasoning or basic assumptions. Okay, let's look at some examples. Again, let's go back to tossing 2 coins. If you toss 2 coins, this is the sample space, and there's 4 elements: head, 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 tail, tail, head, tail, tail. And again, if you want the event of no heads, that's a simple event. There's only one way to get it. If you want the event of exactly 1 head, then there's 2 ways to get it, so that's a compound event. Or if you even said at least 1 head, well, there's 3 ways to get at least 1 head. That's a compound event. Now, if you said event of less than 3 heads, well, that's the entire sample space, but still a compound event. And if you said the event of exactly 3 heads, well, that's impossible, so that would be the empty set, because you can't get 3 heads if you're only tossing 2 coins. Another example, suppose we select a 3-card hand from a standard deck. So S is going to be all possible 3-card hands. So let's let E1 be the event of getting the Jack, Queen, and King of Hearts. Okay, well there's only one 3-card hand that satisfies that, so that's a simple event. Let's let E2 be the event of getting 3 kings. Well, there's actually 4 simple events that give us 3 kings. So that would be a compound event. And of course, the event of getting at least 1 ace, well there's too many of those to list, but that would be a compound event. And then the event of getting 3 red kings is impossible, so that would be the empty set, because there's only 2 red kings in a deck. Alright, suppose we roll a pair of 6-sided die and observe their sum. So here's the sample space. So if you ever need a sample space for a pair of 6-sided die, here you go. The first element in each of these represents the first die, the second element represents the second die. So, how about the event of a sum of 2? Well, there's only one way out of the sample space that can happen, and that's to roll a 1-1. So that's a simple event. How about a sum of 5? Well, to get a sum of 5, there's several ways to get a sum of 5. And I'll try to show you right here. There's several ways to get a sum of 5, so that would be a compound event. Now, a sum between 4 and 7, that would be, a sum of 5 or 6. There's lots of ways that can happen, so that would be a compound event. There's no way to get a sum of 1, so that would be the empty set. And everything gives you a sum greater than 1. So the event of a sum greater than 1 would include the entire sample space. Now, let's take a look at a more empirical example. Suppose 3 candidates run for office, Smith, Jones, and Brown. And we've determined that based on polls that the probability that Smith wins is 0.58, the probability that Jones wins is 0.12, and the probability that Brown wins is 0.3. So let's say E is the event of Mr. Long winning. Well, I don't see a Mr. Long, do you? So that would be the empty set, so the probability of that happening would be 0. Let's let B be the event that Mr. Jones is winning. Well, that's already been assigned. That's 0.12. And let the next one, let E be the event that Mr. Smith or Mr. Jones wins. Well, all you do is add them together there, 0.58 plus 0.52, and you get 0.70. Okay? We'll do more on this later. Okay, now let's finish up on talking about the probabilities of simple events. If you're given a sample space with all these simple events in there, to each simple event that's in there, we can assign a real number to it, and we call that number the probability of that simple event. These numbers can be assigned in an arbitrary manner as long as they satisfy 2 conditions. One, the probability of a simple event always has to be between 0 and 1 inclusive. So it can be 0, 1, or anything in between. And the sum of the probabilities of the simple events must always add up to 1. If that's the case, then we have an acceptable probability assignment. So let me show you some examples real quick. Let's go back to tossing 2 coins. Alright, now take a look at, look at this probability assignment. Everything is 0.25. Well, they all fall from 0 to 1, and they add up to 1. So that's acceptable. Alright, look at the next set. All of these add up to 1, and they all fall in the range of 0 to 1. Look at the next set. If you add these all up, they all add up to 1, and they all fall in the range 0 to 1. Now, if you look at these 2 sets down here, you'll notice that either in this set, the probabilities don't add up to 1, and down here you'll get probabilities that fall outside the range of 0 to 1. Like you can't have a probability of 1.2 or negative 0.4. Okay, so those examples would be unacceptable. These examples are unacceptable, whereas these examples are acceptable. Now, I'm not saying you would choose any of these 3, but I'm just saying it would be acceptable if these were used. Go back to my 3 candidates. This is acceptable, 0.58, 0.12, and 0.3, because they satisfy the 2 conditions. But this is not acceptable because 0.8, 0.12, and 0.30 does not add up to 1. So that would be an acceptable probability assignment. So on the next video, I'll start with how to find the probability of an event E.